Hi everyone. I'm going to talk about annotation-efficient language model alignment via diverse and representative response text. So this is a work on language model alignment, and the code is available. And we also have a PyPy package, which you can install by this pip install apo command. I believe this research is quite empirical, and you can use it for various purposes. So please have a look at it. So what is the problem we're going to tackle? The problem is preference optimization, but under annotation budget constraint. So in real application, preference annotation is often much expensive than the cost of computation, especially for domain-specific annotations, for example, in medical domains or a law or like some domains where you need a specialist for annotations. And even if you don't need specialists, to get a high quality annotation, it's very um, time consuming and also money consuming because although there are lots of platform for crowdsourcing, if you want high quality data set, it takes a lot of energy and cost. Um, so that's the problem we want to tackle. And what we're gonna bring is a method to solve this, which is described in this figure below, which we're gonna explain it one by one. Okay, so we have three desiderata of the preference datasets. We claim this is what we found in prior work, or a compilation of like prior work, which I have a list of reference in the paper. So basically, you want to have good quality and quantity of instructions, and also you want to have diversity on the response text and the representativeness of responses. So, on the diversity, a lot of people do care about this, and there are several work on like how to get diverse responses. Representativeness is there are several work by mainly by reinforcement learning researchers on the topic of on-policy learning versus off-policy learning. Um, in short, you want to have responses that are oftenly generated by that generation model, the LLM. And what we do is that we focus on how to select diverse and representative responses from a set of candidate responses, and then annotate only on the selected responses, so that instead of annotating over, say, hundreds of responses, we select 2 out of 100 responses, and then ask the annotator to label on the 2 which we select that we maximize the diversity and the representativeness of the 2. In this way, we get to annotate with few annotation budget per instruction. In that way, we can also improve the quality and the quantity of instructions. So that's what we want to achieve. And this is a framework which we call annotation-efficient preference optimization. So, as I briefly explained, the process is very simple. You have an LLM and let it generate, say, n samples or output responses from that. And instead of annotating on all of them, we select 2, or it can actually be any number, but say 2 samples which have enough diversity and also a good quality or representativeness of the language model. And then we annotate only on these 2 because we don't want to, because the annotation is very expensive. So we want to select responses which are worth enough to ask human for their annotation effort. Okay, so that's the idea here. But the question is, how do we select the responses that are diverse and representative? So we have two heuristics for selecting what's good for annotation, to be clear. So first, we have a heuristic, or I would say assumption, that representativeness is important, which is we have several anecdotals from RL researches on policy learning. So basically, we want to annotate representative responses because it's more, you know, oft you get it often from the language model. So that's why these responses are important. The other thing is diversity, which I think it is intuitive. You don't want to have a two copy of basically the same responses because then the annotation doesn't make sense. You want to have different enough two responses so that the preference over the two are meaningful and informative for the agent to learn what is preferred by the human. So how do we select these representative and diverse sequences out of, say, hundreds of responses? So we can actually do this by k-center or k-median, or like there are a series of algorithms for clustering. So basically what we do is that we compute the embedding of these sentences and select the responses that um, captures the distribution of samples with k sentences. So for example, on the figure is um, sentence embeddings of the responses embedded into a two-dimensional space, and the red points are the selected ones. You can see that these are, well, um, good enough in representativeness to, model the whole distribution and also have enough diversity between the dots. So we're gonna assume that they're gonna be a good candidates for the annotation. So that's how it works. Okay, so it's an empirical science, so the idea looks good, but the question is, does it work in real life? It turns out it actually works real well. We have compared against several baselines, including core-set approach and also perplexity-based, heuristics and several other baselines. And we found that APO achieves good improvement in various scenarios. We have tested on the multiple algorithms, multiple loss functions, multiple models, multiple reward function, etc. But we consistently find that APO outperforms all the other methods. So I would say it is like good to go algorithms under the fixed annotation budget. So of course the disadvantageous part of the algorithm is that it increases the computational cost because you need to generate n samples and then select 2 out of the n samples, which is also time consuming. But if you have annotation budget and annotation is expensive, then it totally makes sense. So you can install it by pip install APO. It is very easy to try it. It's compatible with Hugging Face datasets. It also takes in CSV, so it's very easy to use. The code is available. So it's a good, nice, practical algorithms that I want you to try. Thank Thank you.